So this is Annual Mondays, and I am Bethany, and Julie is my fabulous co-host for this. So we want to talk just a little bit about how we see a study group thing as opposed to a lot of the webinars that you may see on our website. So we do a lot of webinars where people present on a specific topic or library or project where they are presenting a lot of the time. This is much less formal. I know I'm doing slides right now, but really we want a study group to be probably slightly slower paced than it would be for a webinar and participatory. So we're really expecting people to stop the group, ask questions, work through things. And this is much less of like experts giving forth information and more we as a group kind of deciding the topics we're studying and the facilitators being maybe slightly ahead of the group, but not like with PhDs in this. So this is, it's semi-regular and ongoing. We expect it to be fun. We want to increase our knowledge together. And that also means it's okay to mess up in public, right? This is not about perfection or always having the right answer. We're also collaborative. We want to do it together. And also this means we're not going to be really creating a whole bunch of notes or slideshows. We will record the sessions. We are going to provide a repo for community notes and code, but this is also about you kind of digging through stuff as well and maybe bringing resources to the group.
Yeah, that's a good thing about this. I like that.
Yeah, so what we are going to do is we're going to provide some materials for the topic for each session ahead of time, and we're going to be posting an outline for feedback in Slack. We're going to do overviews of topics and starting a session with a discussion of the topics as a team after this first one. And if more time is needed, we want to have the freedom to schedule additional sessions. So for those of you who are less familiar with Python, if you feel like we need to slow down and go through a topic, we will. Although right now we just have planned to kind of review the basics and then jump into some math, but we can change that. And practice exercises, we have a little one for this one about like making a protein from DNA. We're happy to discuss those online, but we're also really encourage you to get into the Slack channel and talk about those as well.
Yeah.
All right, so I think that those are all of the preliminaries, which took a little while. And I don't know, Julie, do you want to start with some of the ML overview?
Yeah.
Okay, no so I'm going to go ahead and stop sharing, and I'll let you go ahead and start sharing.
Okay. All right. Okay. Tell me if you can see my screen.
I certainly can. Speak up if you can.
Perfect. Yeah, tell me if you can. So you can see that too?
Yep.
Yeah, okay, perfect. So, thanks to the slides, what exactly is machine learning? I'm new to this. I'm completely new to this. So I didn't know what to expect, really, because when I think of machine learning, I think directly about artificial intelligence, but it turns out it's way, way, way more than that. So we have a few definitions. Machine learning is an application of artificial intelligence that provides a system the ability to automatically learn and improve from experience here meaning data, without being explicitly programmed. It's basically taking what we have, data, and going to what we want to know, prediction for new/unseen data. An ML model takes patterns from the data provided, learning from that data, and there's a difference between learning and remembering. Remembering leads to overfitting, and we'll discuss that later, even I don't know that right now. So, Bethany, can you tell us a little more too? Because, like, as I said, I'm new to this, so I knew there was artificial intelligence, machine learning, neural nets, and then deep learning.
Yeah.
Which is like the most complicated, maybe. Deep learning?
Well, it feels complicated, and when you see diagrams about deep learning, it looks complicated, but the difference between, say, deep learning and neural nets is that with a neural net, there are layers of equations or transformations of the data that you set up, and one layer feeds results into another layer that then further transforms the inputs. And with many of these neural nets, and they have proliferated in recent years, there are all sorts and types that we will be digging into later of how they are configured, and how the there's this thing called the back propagation algorithm, how errors are balanced out across this. But typically with the neural net, you know as a programmer what transformations generally the layers are doing to the data. In deep learning, you actually set up an algorithm to make those layers itself. So the layers themselves are generated in the process of training the model. And it's deep because you yourself as and please someone also, Kunal or someone else who knows a little bit more about this than I do, but it's called deep because the layers themselves are somewhat unknown to the program. So
really? So it goes that deep, actually.
Yeah.
Okay, I see.
So it's kind of a fascinating thing, and it almost starts to sound a bit like magic. It isn't. There's a lot of math and probability that gets fed into this. But yes, with deep learning, those intermediary layers of transformation in a neural net are not known or planned ahead of time. They are wholly or partially generated on the fly.
Okay.
Yeah.
And we will see that later.
Yes, we will. It's magic with math. I love that. And Kunal like, it is mathematical magic. It is. It is a fascinating thing. So machine learning a lot, and I think this is one reason why people struggle with it, is that you could get very, very pedantic, and it can also, the quote unquote classic machine learning can feel quite old fashioned compared to the magical results that you get with deep learning, but it's all part of a continuum. So yeah, and so let's see, we kind of skipped over a few slides. So the general principle of this learning from data is you have ultimately a mathematical model that you believe represents represents the path from the data that you have to the prediction that you want to make, right? So an equation that transforms your data. And so you call that the model. I'm sorry, I cut you off. Please, Julie, go ahead. Hello? Julie, are you muted?
Wait, try to talk a little. Oh, that's so weird. I don't know if it's my Wi-Fi, but I feel like try talking.
Oh, are we canceling each other out? Oh, all right. We'll have to remember to take turns.
Hear you, maybe. Right, I think.
Okay.
Okay. What exactly is machine learning? The more we teach the model, so the more data and patterns we feed it, the better it can predict outcomes in data, and it has not encountered before. Of course, the model is only as good as the data and patterns it's fed. Something will be revisited often. And there's an example, like remember how you learned to ride a bicycle, and now in theory, we can teach a machine to do that now. So that's why it's fascinating for me anyway.
Yeah. Yeah. Well, and go ahead.
Tell me.
No, I was just going to say, if any of you have seen, there's another new video released by the good folks at MIT who like to play with four-legged robots. And it's very funny because it's a herd of small robots learning to play soccer and do flips in the quad at MIT.
Really?
Yes, and it can be kind of these sorts of videos are really fun, but can also be a little bit frightening because, of course, these robots they dispensed with like anything looking like a head, but they are quadruped, so they look like little metallic dogs, but without heads.
Oh yes, yes, what you mean. Okay, now I see. Yeah, it's
Very interesting. Yeah. So we have a question from Pooja. Will we be viewing mathematics before we get started? Yes. So this is an overview session, and this is kind of a plunge into all the basics of Python to kind of orient people. But our next session, as we are planning it, is definitely going into the math. I don't think we can avoid the math, and I don't want people to be scared of the math. But we do have to we do have to go there, right? All of this is based on statistical distributions in data, and so we have to go through that. Yes. All right. Sorry. Now I will stop interrupting. Next slide.
So we have different applications for machine learning. The first one is finance and business, like stock price prediction, housing prices, economic policy analysis. The second can be healthcare, so about classifying cancer, predicting risk factor for diabetes, mental health intervention. The third one is your personal assistants, like at home if you have a Google Home or an Alexa. You have also Siri and the smart search. Also in the fourth position, we have spam filtering, like promotion and social emails. Then we have product and entertainment recommendations, so Netflix and Amazon, for example, and also sentiment analysis, elections, trends, and advertising. So I did a lot of some research about the layman's PDF, right? And there was so many like examples of applications for different types of machine learning, because it can go way deeper than all of that. And here we have more specific examples, like predicting survival on Titanic, the most famous cargo data set for beginners. I didn't know that, actually. That's a thing.
That is, and it is, you know, the phrase beat a dead horse. That data set, because it's historic, so people have this this practical thing in their imaginations about the Titanic and what happened, and of course there's a popular movie about it, but also there are records. Like, we have absolute solid records of everyone who was on the boat. We also have records of the people that they rescued, and so because of that, it's considered a pretty clean, well labeled, right? Because researchers and historians have gone over this data set. And so, yes, I believe that you can actually, there's that one and one called the IRIS data set that I believe come with sci-kit-learn, which is a Python machine learning library, as sample data sets that you can do, you know, apply different algorithms to things.
Okay, well, that's good to know. I didn't know that. We have also facial recognition, which is a famous one. Responsive chatbots. I don't know what chatbot is. Like, I know it's not spam. The chatbot is like,
so a chatbot is, it is a compound word between chat, like what you do on in Slack, and robot. And so it is, so it's an automated, it can be more or less obvious or more or less automated kind of responder. And some of them can be quite good, although there's sharp limitations, right? Because just like with Siri and with Google Home and things, it's about recognizing parts of speech, right? It's about recognizing natural language and responding. And as it turns out, humans take very unkindly to things that get into what's called the uncanny valley. So if you're trying to fool a human into thinking that they're interacting with another human, the closer you get without hitting the target, the angrier usually the human, or the weirder the human feels about it. They're like, something's wrong with this, but I can't tell why, right? So,
really?
Yeah, so often, often chatbots these days are, they make it obvious that they are a bot, and the ones that are the most successful tend to kind of be task oriented for humans, so that you don't get into that situation where things feel slightly off, but you can't tell why.
Oh, okay, that's interesting.
Yeah.
Okay, so it's go. Oh, wow. Oh, that's fascinating. I love it. We also have classifying handwritten digits, MNIST. Boston housing, predicting housing prices.
That's
traffic congestion,
too.
and many, many more. So that's interesting. But yeah, there's so many applications. Like, whoa, it goes way farther than I thought, actually. So applications for machine learning, it's easy to think of this whole thing as a bit of magic. Like I think it's like one of the first things that comes to mind, you know, when you hear like machine learning, like, oh yeah, it's doing it on itself. Sometimes you don't really take the time to be like, oh, is there a teacher? Is it supervised or unsupervised? And we'll see that just in a second. So yeah, often we can see it like a bit of magic. Stuff goes into one end of the black box and out pops predictions. But it is, of course, a lot bigger than that. In fact, there isn't a general purpose model of AI that simply fits all the scenarios. And for now, we haven't yet recreated our own brains in code. Instead, there are different strategies and models of learning for different applications and types of data. And I found that actually very fascinating, because when I first started to learn about machine learning, AI, etc., I was like, oh, what if we can map the brain? Like seriously, like you take the brain and you map it in code. And then I saw that, I was like, oh, so okay, it's way more complicated than I thought.
Yeah. Well, and different teams keep trying to get close on different tasks, which to me is very fascinating. So one of the most recent was, and I will have to post this in the Slack channel later. I'll probably mess up the details, but there are a bunch of teams, research teams worldwide, who are trying to build an AI that is able to both ingest and manufacture written text. So essentially reading comprehension. So able to ingest a piece of text and then tell you what the subject of that text is. Something that, you know, oftentimes, at least in the States, you know, is a reading test you give to fourth graders, and then again in high school, and, you know, and then again as an entrance to university. And it's a task that humans, we learn, right? Because we communicate with language. And it's interesting because there'll be teams that make leapfrogs in teaching a computer to do this. And then we stop and ask the question, but is it because there's a statistical pattern? Like the article that I was reading, there was a team that seemed to have an algorithm that was frighteningly close to what a human would do. And yet then when they went back and looked at the data that they input, the data itself had a bias that was a distinct pattern. And so what the algorithm was learning was not comprehension. It was learning the underlying pattern in the data set that had been collected and was able to make predictions. And so yeah. So then you have to ask yourself, so what is intelligence? You know, and then you start, anyway, there's all of those philosophical implications about this. It's like, well, is that what a human does? What is comprehension if it's not that? So, yeah. Anyway. Okay, well, we could, let's see, applications for ML. Let's quickly go over the types of ML. I don't know if you want to, you're still sharing your screen. Do you want to go down to the types of ML tree really quick?
Yeah, I read it.
For your screen, if you just go to that slide, I think you're still on the slide that is what exactly is ML. So if you want to go down to the types of ML in your slide presentation.
Oh, can you hear me?
Yeah, I can hear you.
Oh, I couldn't hear you. What did you say? I'm sorry.
Oh, if you advance the slide deck to where the types of ML slide is.
Like that? Oh. Like bigger?
Well, here I'll share my screen. It's okay.
Yeah, share.
Let me share my screen. Yeah.
Okay, go.
Can you see that all right?
Yeah, perfectly.
Yeah.
Okay.
Yeah, so it was this slide that I meant. And I'll make it slightly bigger here if I can.
Oh, right. That's why I was.
I don't know why this is not. Not. There we go. I have to go the opposite direction. Apologies, people. Okay. Hopefully you can see that fairly well.
It happens.
All right, so this is, as we're going over this is classic machine learning. And like we said, different types of machine learning go for different applications. And in the classic model, before we get into neural nets and those sorts of things, you've got what's called supervised learning and unsupervised learning. And in supervised learning, you have what's called labeled data. You know what factors you are looking at and you know what result you want. And so your training data has all of those factors and the expected outputs. So a classic example of this is things like spam prediction. You know what spam looks like, or we define what spam looks like. And we define what is not spam, and we have that labeled. And so we know that you know, email that is urgent about fertility pills that are all herbal, right? We know for sure that needs to go in the garbage bin. And so our data set is labeled, and we train on that data set, and then we feed the algorithm another set it hasn't seen before, and look at the predictions it makes and adjust them based on what we get. But we kind of know, we have a group of expectations ahead of time. So there's classification, there's regression. So classification, that would be a spam filtering one, right? You're either in or you're out. Regression would be more like the Boston housing prices, where like we know in general that the more bedrooms you have, the higher the price. There's this straight line equation that like increases the value based on a certain combination of factors, generally. And
also, like, I would add, like, regression is also with numbers, and classification is more with predict category. So it's two different things actually. And also that supervised means that I'm sorry, it has a teacher. Actually, the machine has a teacher, so all the data is labeled and the machine knows, like, oh, this is that, this is this, etc. And the unsupervised, like, you have, the machine has absolutely no data is labeled, and you have no teacher. The machine has no teacher.
Yeah. Yes, and what's fascinating about this, about unsupervised learning, is you would think that there would be no way to make sense out of that sort of data. that it just wouldn't work. And yet, when you apply something like k-means clustering, you can go through and you can cluster data, and those clusters can have meaning made out of them. For instance, you know, for route planning, or for temperature prediction, or for cancer detection. That, as it turns out, you know, there are features in common with malignant tumors that do not show up in general for non-malignant tumors, and that data will cluster. And association. And association is also fascinating because humans are just full of biases. We are. And sometimes we cannot, for whatever reason, because it's subtle, because of the detail, or because we are blinded by assumption, we cannot see an association that an algorithm can then see. Now, algorithms themselves can be biased, but it is interesting that there are associations that get, like with data mining, that get revealed that you wouldn't expect that you can use an algorithm on.
Exactly.
So, okay. What else is there here? Let me enlarge this again so I can see.
Do you guys have any questions, like, or any notes that you want to tell us about all of this? Like, I didn't know. I knew like there was some type of machine learning, obviously, but I didn't know the specific terms or what it did. So did you guys already know that, or just realize it now? Tell us in the chat if you have anything to share.
Yeah, pop in there and let us know that. Yeah, and so this slide here is again in words, just supervised, unsupervised, and then there's also two other categories. There's semi-supervised, and there's also reinforcement learning. Reinforcement learning is a really fascinating area as well. In fact, the data science track recently did this thing where they trained, it was a simulation, but they trained a little lunar lander to land on the moon within a certain area at a certain attitude, meaning, right, the lander, in order to work correctly, had to land on its tires, right, and not on its side. And they used reinforcement learning to do that. And that is really interesting, because it almost feels as though you really are teaching a child how to do something. And the way that, oh, go ahead.
I was just saying that's so cool. Like, I love that.
Yeah, and so you can literally see, they have a video up, you can literally see the thing kind of, you know, it fires one jet and kind of goes cattywampus, and then it adjusts itself and adjusts itself. And mathematically, the way you do that is that if something is perceived to be closer to the outcome or the goal, it will end up with less of a penalty. A penalty being, you know, an adjustment factor, some number, and so the machine goes through in thousands and thousands of cycles, and gradually things that move it in one direction or another get reinforced, right? They have a reward, like a, you know, positive value attached to them or a negative value attached to them that continues to skew the results towards the intended value. Yeah. All right. So, but for the purposes of this session, we have to walk before we run. So now we rewind all of this lovely talk and we start talking about the nitty-gritty of Python, which for better or for worse right now is the machine learning language. So although many, I would say, and I'll stop my share here, many JavaScript developers and many Go developers and quite a few C++ developers would beg to differ that it's only Python you learn for machine learning. Because
really?
Of course, machine learning's been going on well before Python was made. and then before Python got popular, and no doubt will continue. You know, and there's various other languages. There's Julia, there's Scala, there's all sorts of languages for processing, ingesting data, and for training algorithms. One really well-known library, TensorFlow, which Google put out, now doesn't just have Python bindings, it has JavaScript bindings, and it also has Go lang bindings.
Yeah.
So, yes. All right, I'll stop.
I'm gonna share my screen. Hopefully the connection won't crash again. All right. Up. Tell me if you can see the notebook.
Definitely.
Hopefully.
Oh, and I should let me put the repo link in the chat so that if we have issues with this, you can always take a look at this in Colab or Binder, or download the notebook yourself for later. So, there we go.
There's so much, I don't know where to start.
Well, so if the people who are left chime in, either you can take yourself off audio or type it in the chat channel. We know that one person here at least is mid to advanced in Python, but the other two of you, what's your experience with Python, and where would you like to start? Because this really is a complete rundown, starting with like strings and all the detail. But if it's not necessary, then we can skip straight to, you know, practicing comprehensions or slicing, or having a general discussion about different features of Python. But this is really up to you guys. So Julie and I are going to be quiet for a minute.
we will let you chat.
Jasmine, Catalina, your level of Python and your interest in where we start with this review?
Yeah, tell us like where, or even in Python, where do you have issues, or if something is quite hard to understand, or if you want the whole tour. I don't have, oh yes, I have the combo. Anyone?
Uh-oh, we have, okay.
I don't mind the review, but can start anywhere.
Jasmine, how about you?
Yes, please let me know. I didn't see the message. Yes, it's magic with math. I love that.
Yes, it's magic with math.
But I'm so scared of math.
Uh-oh. All right. Well, yeah, I mean, we can just, we can kind of, I guess, skip around and things if you want. Julie, what about you? As you were going through this, you're a bit newer to Python. What are some of your sticking points?
So I'm watching it right now. The denote single line in 9, that's okay. I got that. So yeah, yesterday we were talking about classes, but I don't think you put them in there. That should be another topic.
Yeah, that can be a discussion for later. Although if the rest of you all want to get into doing classes, we can do that. Unfortunately. Oh yeah, there's the I don't know if all of you are very practiced with indexing and slicing of strings and lists, although that skill can kind of come in handy as you do NumPy and Panda stuff. So
that's
if you click on the details button,
this one.
Yeah. So
this is so tricky. For me, this is actually like, oh, it depends on when you start and where. Oh my, every time my brain is like, what?
Yeah. Which is why I drew this out for myself, because for a long time my brain was like, huh?
Yeah, exactly. Seeing it right now is easier. Knowing also that Python always starts at 0 and not 1.
Yep.
Ta-da. So we have it here, slice index. So the first number will be the start, and then 2 columns, and the second number will be stop point. So here, if we want to take only the letters, the first 3 letters, what? You have to be column 3, so to be like 0, 1, 2. That's why it's tricky for my brain, you know, because you want only the 3 letters, but you have to be like 0, 1, 2, and that's it.
Yep. Yes. The right-hand side is exclusive, which yeah, that screws it up a lot. Yeah.
You can also do it backwards, like starting here. And since it's exclusive, you get those ones.
Yep.
And then for orgs, it can be like 6 or -4. And for only work, 5, 9, or -5, -1. Like 1, 0, 1, 2, 3, 4, 5. 5 included. And 9 excluded, right?
Yep.
6, 7, 8. Yeah, 9 excluded.
Yeah.
So that's interesting.
Yeah. So indexing from the right-hand side can sometimes do not so nice things to your brain. Notice that you have to do -5, -1, and what you get is WORK. So yeah.
I can hear you. Oh no, my Wi-Fi is completely crashing.
Oh no! Oh no! Is it better if I do the notebook, or I don't know? We're just gonna have to muddle through. But
I'm hearing you. Can you hear me?
I can hear you. Yes.
Oh no. Oh okay. Not synchronized.
Uh-oh.
Tell me when you hear like this.
I can hear. I mean, I hear that.
Oh my God.
Is
Try
it
to
better?
share your notebook.
Okay, I'll go ahead and share my screen. Apologies.
Yeah.
Everyone.
Apologies. Sorry.
Yeah. Okay.
It's the first session.
Desktop. All right. Okay. Apologies. Can everyone hear me and see me okay? Let me scroll down
Yes,
in
perfectly.
the notebook.
I'm so sorry, I missed my Wi-Fi. Oh no.
That's okay. This is why we have 2 presenters. Okay. Yeah.
Yes.
So one of the gotchas for me is, yes, indexing works from either direction, but so do the rules. So if you start at the left and go to the right, then right. But if you start at the right and go to the left, so for work, notice -5, and then you have to do -1. What I really love though about slicing is slicing applies also to lists as well as strings, and the rules are the same. And actually, slicing also applies to NumPy arrays and to n-dimensional arrays in NumPy, and also to slicing in pandas, which can get really interesting because instead of 1 dimension, you can have 2 or 3 dimensions. And so it's a lot of columns. Yeah. Yeah, because in pandas, if you think about pandas is sort of Python's version of headless Excel. And so if you think of Excel spreadsheets, you can have more than 1 spreadsheet in a notebook, right? And you can do a slice that is through the different spreadsheets at 1 cell, or you can do a slice that is 1 column of 1 spreadsheet, or 1 row of 1 spreadsheet, or multiple, like 1 column across 3 sheets, or 1 row across 3 sheets. So if you think of it as like a cube or a matrix, yeah.
So nice.
Yeah, and so the other cool thing about this is really this syntax is start, stop, step. So if you, I like the step part of this, so you can do every other letter or every third letter, or my favorite trick in Python, which I'm sure everyone listening knows, and people from other languages get really angry at us Pythonistas for this. They'll be like, okay, you demonstrate you know how to program, reverse this string. And you're like, okay, you know, bracket, colon, -1, bracket. Walk it backwards. Python's like, yep, walk it backwards. And it's considerably more complicated in, you know, in JavaScript or C. So that's my favorite sort of trick. We have exercises in here, but we can also leave those for you to play with yourself. And I'm going to kind of skip over this. I just want people to know, I don't know what your experience is with this, but Python has a long, twisty history of formatting strings. So it first borrowed C syntax, which is percent syntax. I can just show you these examples. It's called percent formatting. And you see a lot of people default to this because it's old and it's well known, and people do that. But then Python implemented this thing called a template string, which
I didn't know that actually. When I was looking at the notebook, I saw that. I was like, oh, what is this?
Yeah. This is recognizable if anyone's done bash scripting. This kind of looks sort of familiar because that $sign is the way you declare a variable in bash scripting on the command line. And I guess this, if you look at this thing up here, when you're dealing with data that is like raw input, oftentimes they recommend that you do this in Python, that you use a template string. And the reason for that is because, of course, you can't trust users. And so you don't want to use something like dot format or string interpolation, because the interpreter will execute it directly as code immediately. And so that allows somebody, if they're putting in input, they could put in code that's malicious. So this template string is a way of protecting the input, or protecting yourself from malicious input, right? So that's one of the reasons why they recommend that method for when you're doing it.
Okay.
Oh goodness! Oh, it's past. Holy cow! Yes, please. We want you to go to sleep, Pooja. But join us in the Slack channel. Feel free to download the notebook, and maybe we adjust this time too, depending on what core group we have. Thank you so much. Yeah. Yay. All right.
Thank you so much for being here.
Yeah. All right, I'll just do a little bit more of this, and then maybe we let everyone we let everyone go, and you can work through this notebook on your own and the exercise, and we can chat in the ML Learning Slack channel, and do some math next time. But
oh my god!
All the math, it's easy. It's easy. It's easy stuff. No, it's intimidating as all hell, and probability really, really kicked my ass when I took it, but I think it's also worth the effort. But I'm getting ahead of myself. So format strings. So then as Python evolved, Python did this thing called a string.format method, where what you do is you put in little curly braces in the string where you want something to be replaced, and then you call the format method with the parameter that you want replaced. And then, because they'd already started down the slippery slope, by the time they got to Python 3.6 and higher, they went straight to what's called string interpolation. And so instead of calling the dot format method and putting the input through there, you just use curly braces with this little signifier ahead of it. And that signifier tells the Python interpreter that when it hits this, it takes it as a code block. For most intents and purposes, that means that, you know, it just does a variable replacement, but you can do some really interesting things. You can write a loop in here, and the Python interpreter hits it and it executes the loop, which is why you don't want to let a user, you don't want to use this for user supplied input, because it could execute the code immediately, right, when it hits the parentheses. That's the interpolation part. But these are really, really fun. And so there is, oh, sorry, this notebook was not authored by Google. I'm getting this annoying message. Let me see, up here, I think is a code example where, yes. So, oh no, there isn't a code example. I apologize.
I don't think that's one, yeah.
Yeah, there isn't, but I can paste one in the Slack channel later. There is a piece of code that will actually produce this report, and you do it using F strings, and you can see how somebody you can compose something fairly complicated using an F string.
Okay.
And things like that. All right, so I think I'm going to kind of skip over this indentation and things unless someone has wants me to actually go over this. I think we have about 10 minutes left. So what do you think, Julie? We can take a pause here and chat a little about what we want to do next, or?
Yeah, we can do that. I mean, I don't know if people want us to continue on the notebook, but they have the link to the notebook. Yeah, you put the link to the notebook. So you guys have the link and you can check it out and try the exercises too, if you want. It's good practice, actually. That helps me a lot to practice again and again and again in Python. That's how you learn, just not in theory, but also in practice. What else?
You know, from here, so I think one of the difficulties in kind of tackling ML is that while a knowledge of Python certainly helps so that you're not constantly looking things up, a lot of the libraries and a lot of the things that you learn or use don't feel like they're strongly connected to, you know, writing general purpose programs in Python. But people feel like they need to master all of the Python detail before they move on. You don't necessarily need to. I mean, it certainly helps to know how to import things. It certainly helps to know how to read a stack trace. The principles of programming definitely help. But you don't have to have like written an entire application in Python in order to learn the steps for ML. So that's why also we're not spending a huge amount of time on Python, but if there's interest or there's questions or you're really struggling, we want to make sure that you're not left out of this either. So that's kind of the balance we're trying to strike here, but we don't want to bore you to death either. So. Julie, go ahead.
Yes. So yeah, I mean, I think that it would be very nice for next time or even for your time zone to be very interactive, a little more than today if possible, because since it's a study group, you know, like only reading documents won't really, how would I say, take us far, because if I'm going to host like something like this alone, like I'm not an expert, and I don't think like people are here to hear an expert talking about machine learning and deep learning, etc. More than you know, trying to learn all together. And I think it's good to have the Slack channel so we can put all our exercise in it and try to do stuff together, but also to be interactive during those study groups. Know what I mean?
And if someone else doesn't talk, I am just going to blather and blather and blather, and no one, including myself, wants to hear me do that. Save me from myself.
I'm thinking like more So yeah, next time we want to do math, right? You and Yashika are working on that?
We are, and so we are probably going to be doing a blitz similar to this Python blitz, but the blitz is
Yeah.
going to be around linear equations, linear algebra, statistical
Oh.
distributions, and some touching on what, and if you'd like to prep for next time, what exactly
Uh-huh.
do we mean when we say random variable? Uh,
Yeah.
and don't drop down any of those trapdoors or get intimidated by that, but that really is the concept of a random variable is where this whole thing starts. And
Okay.
I was really fascinated when I found out what a random variable is, because I know we all know what, we're programmers, we know what variables are. And so you'd think, well,
Mm.
a random variable is one that's just decided randomly. But it turns out there's more to that story. So that's a little of what we're going to be going over next time, including also, please bring your questions about Python back to that session. We've planned about half of that session being dealing with people's questions or comments about the use of Python. So
Yes, exactly. And also, what do you guys want to know more about machine learning, about Python, about math? Some of the topics like where you feel kind of a little lost, or some of the topics that are a little complicated, or not at all. I don't know. So since the study group, like everyone can help everyone, and that's the beauty of it.
yep, I agree.
I think we're good.
Great. Well, thank you again for sticking with this and for joining
Thank
us
you.
in the evening or even late at night. And hopefully
Yeah.
you will come back next week and join us for more shenanigans. Or not next week, actually, in 2 weeks.
2 weeks?
In 2 weeks. We're going to do this every other week, yes?
Yeah, perfect.
Okay, great. Thank you so much.